All right, ladies and gentlemen, we're going to go ahead and dive into lesson 8-2. So if you would follow along in your notes, that would be great. Go ahead and make my pen a little bit bigger here. 8-2. Today's focus is going to be the area of parallelograms. All right. Now, if you recall from our previous notes, a parallelogram has this sort of slanted rectangle shape. Like so. Now, the word parallelogram means that there are going to be sets of parallel sides. So parallelograms have two sets of parallel sides. A rectangle is a special type of parallelogram, as a matter of fact. Like if I were to look at a rectangle here, a rectangle also has two sets of parallel sides. And you can see the little carets here. So the little blue marks indicate a set and the little red marks indicate another set. What's unique about a rectangle is it also has four right angles. A square is also a type of parallelogram. So let me draw a square here. Okay, a square has two sets of parallel sides and four right angles. So it's also a type of rectangle, but what makes a square unique is that it also has four congruent sides. Okay, and then a rhombus, which is a slanted square, okay, a rhombus is also a parallelogram because it also has two sets of parallel sides. So we have all sorts of parallelograms here. The special parallelogram known as a rectangle, or the special parallelogram known as a square, or the special parallelogram known as a rhombus, or the just generic parallelogram, like this one right here. This is the one that we're going to be focusing on today. Okay, now, to find the area of a parallelogram, we can use the same formula for all of these. So, you know that the area of a square is just the length times the width. Or in some cases, we call this the height. Okay, so for our purposes today, we're going to call it height. Length times height. Length times height. And in the case of this parallelogram, it's length times height. Now, parallelograms are tricky, so I'm going to go ahead and scoot this over a little bit. Parallelograms are tricky in that when we're talking about the height, we're talking about the distance here. Okay, if I were to, I'm going to highlight this distance, okay, right here. Now, on a rectangle, that's just one of the sides. And on a square, it's also just one of the sides. But like on a rhombus, there actually isn't a side there. And this diagonal here does not count. You can't use that. It has to be the distance between the parallel sides that is perpendicular. So where it forms this right angle. And in the case of a rhombus, or in the case of this parallelogram, there actually isn't a side there. So, what we need to do is we need to look at the formula for the area, and we need to look at why the formula works. So, let's start with a generic parallelogram, and I'm going to go ahead and draw one here. Okay, like so. Okay, so there's my parallelogram, and what I'm going to do is I am going to cut this parallelogram up a little bit. I'm going to say, I'm going to cut this end off the parallelogram right here, that triangle piece. I'm going to cut that triangle piece off there. So I'm just going to go ahead and I'm going to copy this. Like so. And then I'm going to erase the pieces that I didn't cut. So I cut that piece off. Okay? So that piece right there. Now, if you were to take that piece that was cut off, so let me just go ahead and erase it off the end of this here. If I were to take that piece that I cut off and I were to move it over here, you would see that it fits like a puzzle. And that I now have a rectangle like so. Okay? What this shows us is that the area of a rectangle and the area of a parallelogram can be the same, it's just that the parallelogram is slanted. And that means that they both can use the same formula. The length times the height, or in some cases you call it width. Now, so when we measure, or when we are trying to find the area of a parallelogram, we are going to do the following, we're going to use the following measurements. I'm going to go ahead and bring back a parallelogram. So okay, there's a parallelogram. When you measure a parallelogram, many times you're going to see a dotted line like this. You'll even see this on page 380 in your textbooks. Okay? And this dotted vertical portion is going to be called height. And they will call this bottom portion the base. Sometimes we call it the length. Okay? But ultimately what you're trying to do here is you're trying to get these two measurements. Okay? So, in blue, you want the height and you want the base. Those are the things that you're measuring, the things in blue. This height and this base. And once you have those two measurements, finding the area of a parallelogram is very, very simple. You would just take and you would multiply the base times the height. Not super challenging by any means. That's it. You know, you just multiply the two values. So let's take a look at an example here. Okay, let's go ahead and draw another parallelogram. I'm going to make it 3 wide across the top. Three wide across the bottom. Working on graph paper really helps us with this, because if we look at each square as being 1 by 1, then it's very easy to do measurements and to draw and to get our shapes to look right. So graph paper is really helpful. In this whole chapter, graph paper will be very helpful. All right, so again, this is going to be a parallelogram that's got a base of 3, and it's going to have a height of 4. So to find the area, it would be base times height. So it would be a base of 3 times a height of 4. And remember, we're doing this in units, so I'm going to put little u's right there and right there. Okay, and then this is going to work out to being 12 units squared. And again, the units squared, we talked about this in one of our previous lessons. Anytime we're working with area, our units are always squared. Okay, so this would be 12 units squared. And so that's what you're doing here. Okay, now I am going to give you a slightly different kind of problem. It's going to look like this. Okay, and just taking a minute to draw this. Okay, there is my parallelogram. And I am going to tell you that it has an area of 45 units squared. And I'm also going to tell you that it has a height of 5 units. So, when trying to solve something like this, we're going to be trying to find the base. And of course, on graph paper, you could make this would be fine. You could just literally count the number of boxes, and you could do so here. However, let's pretend like we're not on graph paper, and so we need to figure this problem out. We need to find the base by using the information provided. To do this, we need to start with our formula. Area equals base times height. And I'm going to convert this down into just single letters because I think that's going to make this a little bit easier. So A equals B times H. Now, notice I have 3 terms in my formula, and I'm given 2 in my problem. This is how math works oftentimes. You're given just enough information to solve for the unknown. If I knew all 3 of these, I wouldn't have a problem. I'd know all the information. If I only had 1, I wouldn't have enough. I need exactly 2 pieces of information in order to solve for a third. In this particular situation, I know that my area is 45 units squared. I do not know my base. And I know that my height is 5. Okay. Now, 5 times b on the right-hand side, right here, that is the same thing as saying 45 equals 5b. 5 times b. 5 times b, or 5b. And this is a problem we've been able to solve in the past. We go ahead and we say, okay, well, what's being done to b? Right here. It's being multiplied. So we need to do the opposite operation. And the opposite operation in this case is to divide both sides by 5. Now on the right-hand side, they cancel out. I carry down b. And 45 divided by 5 is 9. So my base, right here, okay, my base is going to be 9 units. And I can double check that, right? 9 times 5 should equal 45. And it does. And really, this is how you work with the area of a parallelogram. Okay, let's look at one example problem here of how area of parallelograms and rectangles also relates to perimeter. Let's say that we have some information like such. We have an perimeter, or we have a parallelogram, a rectangle, that has an area equal to 36 feet squared. And we also have 26 feet of fence. Okay. This is very similar to problem number 16 in your book. Okay, and this will also play into problems like 18, 19, 20, and 21 in your homework as well. So let's go ahead and just take a look at these kinds of problems. When you are looking at a problem like this, you have to kind of understand first and foremost what it is you're trying to find. So I'm just going to draw a rectangle, okay, because a rectangle is a type of parallelogram. And I'm going to start by saying, okay, I know that the area is 36 feet squared. I also know that the fence goes around the outside of this area. Okay, so the fence is going to be this kind of yellow boundary. I know that whatever value I have here at x must also be the same here, and whatever value I have up here for y must be the same down here. And so I'm trying to find what x and y are, what these values are. One of the easiest ways to do this at this level of mathematics is to look at your factors of 36, okay, to make a list of factors for 36. So let's just do that right now. We have 36. Now, 1 times 36 equals 36. 2 times 18 is 36. 3 times 12 equals 36. 4 times 9 is 36. 5 doesn't go into 36 evenly, and then 6 does. 6 times 6. And once it kind of curves back around here, so we have, 1, 2, 3, 4, 5 doesn't work, 6, and then comes back around 6, 9, 12, 18, and 36. So once it kind of curves back around, then we're good to go. We've found all of our major multiplication factors here. So what we want is we want to find one of these that works for our box. The odds are that we're either going to have like 1 in 36, or we're going to have 2 in 18, or we're going to have 3 in 12, we're going to have 4 in 9, or we're going to have 6 in 6. And so one of the easiest things to do in this situation is to start with your lowest values. So let's just say, because we don't necessarily know it could be a square. So we're just going to start with the values 6 and 6. Those, when multiplied, give us 36. So if they were 6 and 6, then we would need, let's just do the math here. 6, 12, 18, 24 feet of fence. Well, that's really close to the 26, but it's not exactly it. But since it's close, let's try our next set of factors, which would be 4 and 9. Now, the way I draw this, I'm going to draw my 4s on my shorter sides and my 9s on my longer. Okay? Now, 4 times 9 is 36. And when I add up the sides, and I do, because perimeter is 4, plus 9, which is 13, plus 4, which is 17, plus, let's see here now, 9 plus 4 is 13, plus 9 is 22, plus 4 is 26. So 26 feet of fence. So these must be the dimensions that we were looking for. So this mystery box has the dimensions of 4 feet by 9 feet, has an area of 36 feet squared, and to put a fence around this would take 26 feet of fence.